So in this video I'm going to explain how a rotary engine works. Now there aren't many cars built nowadays that still use them, but it is a different method of an internal combustion engine, so I'm going to go ahead and explain how it works. So we've got this rotor here inside of a casing, and we're going to be rotating this direction. Alright, so what happens is there's a small gap of air right here. And as this rotor rotates, this gap of air expands. And as it expands, it's going to pull in air from your intake right here into this chamber. Now the rotor is going to keep rotating and compress this air into a very small amount of air along this wall right here, as you can see here. Now these right here are your spark plugs, these two right here. And when they ignite, the rotor is going to be in this position, and then it's going to swing this direction, continue swinging, and combustion is going to happen right here. So after that, it's going to keep rotating, and then it's going to push those combustion gases out here through your exhaust. Now, there are several things to keep in mind when you're looking at this. It's probably confusing. So there are two rotors total in the engine. There's one that you'll see in front, and then there's one that's countering that behind it along the shaft. Here's a side view of what it looks like. You've got one rotor here that's going to be rotating, and one rotor here that's going to be rotating. Both are connected to the same crank, that's this circle right here, and rotate in separate housings. So all four steps, I should say, of the combustion are happening simultaneously in the same chamber. At the top you've got the air-fuel mixture going in. Here you've got the combustion phase will be happening. Here you've got the combustion occurring after the spark, and then pushing out the exhaust gases. So the reason you're going to have two of these countering each other in opposite directions is to minimize vibration. If you have the center of gravity on the axis of rotation, you're not going to have any vibration. So that's what they're attempting to do there. Some things to keep in mind. For every 3 revolutions of the output shaft, that's what you get from 1 revolution of this rotor. So as this big rotor, and it kind of acts like a gear here, as this rotor here rotates one time around, this triangle goes completely 360 degrees, this output shaft is going to spin 3 times. So you can think of it as a gear ratio, and this one's a 3, and this one's a 1. So every time this rotates once, you'll have 3 revolutions of this one. Another thing to keep in mind, there are 3 combustion phases per revolution of the rotor. So that means for every combustion phase, you have 1 revolution of the crankshaft. And one of the main benefits of a rotary engine over an internal combustion engine that's piston cylinder based is that there's only really 3 moving parts, these 2 rotors and the crankshaft, whereas a piston cylinder engine is going to have, you've got camshafts, valves, springs, you've got cylinders, you've got push rods. It's about 40 or so components that are going to be moving, so with a lot less moving components you can increase reliability. On the downside, it's harder to get a higher compression ratio with a rotary engine.